Assalamualaikum everyone. My name is Mohammad Abdullah Afzal, roll number 21TE53. Today I am going to discuss Lab 10 of Digital Signal Processing. The objective of this lab is to implementation of FIR filter using frequency sampling method. Frequency sampling design method, in addition to method of Fourier transformation design and Fourier transform with windowing discussed in the previous section, frequency sampling is another alternative. The key feature of frequency sampling is that the filter coefficients can be calculated based on the specified magnitudes of the desired filter frequency response, uniformly sampled in the frequency domain. Hence, it has design flexibility. We have desired filter frequency response, desired filter frequency response. Moving towards task 1 of lab 10. In task 1, firstly we define filter specifications, then use frequency sampling method. After that we plot magnitude response. After magnitude response of frequency design method, we plot phase response, then compute finite impulse response filter coefficients and print FIR filter coefficients. Now we run this code to see the output image. This is the magnitude. In first image we can see the magnitude response of implementation of FIR filter using frequency sampling method. And in second image you can see the phase response. Now moving forward towards task 2 of lab 10. As same, we firstly define filter specifications, then use frequency sampling method, plot magnitude response, then plot phase response. After that we compute FIR filter coefficients and print FIR filter coefficients. We run this code to see the output picture. This is the output image. Firstly we have magnitude response, then we have phase response of task 2 of designing frequency sampling method. Now moving forward toward task 3. Firstly we have filter specifications, then calculate normalized cutoff frequencies, and then use frequency sampling method, convert it to transfer function, then we find magnitude response, phase response, and plot magnitude response and phase response. At the end we compute FIR filter coefficients, then list the first 3 FIR filter coefficients. After run the code, this is the output image of magnitude response and this is the phase response for 7.13. Now moving forward towards B part of task 3. This is the total input code. Firstly we have filter specification, then calculate normalized cutoff frequencies, use frequency sampling method, convert to transfer function, then we find magnitude response, phase response, and plot magnitude response and phase response. At the end we compute FIR responses. After run this code, here we have the output picture of the code. This is magnitude response for 7.14 and this is phase response for 7.14. Now moving forward toward task 3 of part 3 of task 3. Same as we mentioned before, we have filter specifications, calculate normalized cutoff frequencies, use frequency sampling method and convert to transfer function. Find magnitude response and phase response, then plot magnitude response, phase response. Now we check the output image of this. This is the magnitude response for 7.15 and this is 7.13. Now moving forward toward task 3 part 4. As we discussed earlier in the previous codes, we have filter specifications, calculate normalized cutoff frequencies, use frequency sampling method, convert to transfer function, and we find magnitude response and phase response. Then we plot magnitude response and phase response. This is the output image of magnitude response for 7.16 and this is phase response for 7.16. At last, we have part 6 for task 3. Again, we have filter specifications, we have calculate, normalize cutoff frequencies, use frequency sampling method, convert to transfer function, we find magnitude response and phase response, and then plot magnitude response and phase response. This is the output of magnitude response for 7.17 and this is phase response for 7.17. That's all about today's lab. Thank you so much. Allah Hafiz.